Hello, Mr. Barry's geometry class. I'm taking a look at composite figures #1 worksheet. I don't know if these are the words that he used in class, but generally speaking, this is what it's all about. A composite figure is a figure that can be split into two or more figures that are basic plane figures, like triangles, parallelograms, trapezoids, rectangles, circles, etc. To find the area of composite figure, you split up the regions and find each area, then find the sum of the areas. Basically, that's what you do. Probably different words you used in class, but you could use those because it works. #1, and pause this as needed as I'm going through this. I'm going to first of all find the area of the rectangle, and you can see the rectangle is 23 by 12, and that ends up being 276 centimeters squared. Write the formula every time you do it because that's going to help you remember it. The trapezoid at the bottom here, the height is 6. How do I know that? Well, this is 12, the whole thing's 18. 18 minus 12, so from here to here is going to be 6. Okay? And then we have, this is 23 because that's 23 and that's 15. And then I divide that by 2, I get 114. I put them together to get 390 centimeters squared. Let me jump down to #3. You could try 2 on your own. First of all, I do the rectangle. And the rectangle, I figure, is 17 by 9. Because this is 9, so that's this radius, so that means this radius is 9, so 26 minus 9 gives me that 17. So that becomes 153. Then I do the triangle, and it's b times h over 2. That's his. I did my formula. I like his better. 9 times 10 is 90 divided by 2 is 45. So this triangle is 45. I knew that the height was 10 because if this whole thing was 17 here that I just figured out earlier, and this, it says this is 7, that means this leftover is 10. So I have 10 and 9 as my base because once again the radius of this semicircle is a 9. And then to find that semicircle, I actually made a mistake. First, I just found a whole circle with a radius of 9. And then I forgot to take it in half. So I actually came up with this answer first. And I was like, wait a minute, got to take this in half. So I subtracted that half amount, that 127.3, which is, you know, the half. So that I got rid of. And so it's 325.2. Rounded. I'm rounding all these to the nearest 10th, as Mr. Barry instructed me to do so. #5. First of all, I got to figure out the measurement so I could do the square first. I wanted to do the square first just because it seemed like the right thing to do. So the problem was I didn't know this measurement here. So one thing I do know is that this triangle, I have this part of the triangle and I have this part of the triangle. It's a right triangle, so guess what? I could do Pythagorean's theorem. A squared I didn't know, plus b squared equals c squared. So I just took 12 squared minus 9.6 squared and I got 51.84. Took the square root of it, 7.2. So each of these little sections is 7.2. The whole side then is 14.4. So 14.4 squared is this whole square, which is 207.4. Then I went back to the triangles. And the base times the height. So the base, I'm going to do this whole triangle. And the whole base is 14.4 times 9.6 and divided by 2. So I got the whole triangle is 69.12. And then I'm going to take care of this trapezoid here. And I know that this is going to be 11 because I took 25.4 minus 14.4, which is this whole side, and I'm left with 11. So I know the height is 11, and base 1 was 14.4, and base 2 is 10. I know this base here is 14.4 because it's the same as this side, because it's a square, all right? and I get 134.2 meters squared. I add up all of those sections, the square, the triangle, the trapezoid, and I get 410.72. To keep things similar, I end up rounding to the nearest tenth. Shaded regions, to find the area of a shaded region, find the area of the entire figure, and then subtract the area of the non-shaded regions. Not sure if those are exact words that he used in class, but they work. So the whole thing is a rectangle, so length times width, and you get 350. Then I'm going to subtract this triangle, which is 137.5. So I subtract that and I get 212.5 centimeters squared. And lastly, this one, I needed to find out what this is. So if I back it up and I actually put it here, because it would be the same, I know that this was 17, so 37 minus 17, what's left over, this is 20. So I have a right triangle with, I don't know A, I know B is 20, and I know C is 25, so I could use Pythagorean's theorem to figure out that this side is 15. So this side is 15, so that means this over here is 15. So I got the height, in other words, for my trapezoid as 15. First base is 17, second base is 37, divided by 2, I get 405. Then, to find that, that semicircle, I just take pi times 7.5, because that's half of 15, that's the radius, squared. And so I get 88.4. So I take 405 minus 88.4, and I get 316.6 inches squared. Hopefully this helps. Good luck with the evens that you're doing on your own.